I'm a program manager on the Azure Storage team, joined by my colleague, James Baker. And we're here today to talk about the exciting things we're doing on Azure Storage, and specifically about Data Lake Storage Gen 2. I was reading a few days, weeks ago, that we approximately generate around 2.5, maybe even more now because this is old data, petabytes of data per minute in the US alone. That's how much data we actually generate on the internet today. And that's just the data that's being generated. And you can imagine how much of that data is actually being collected and used. And years ago, people might not have really bothered with that. It was data. Yes, it was just going around on the internet. But now we have the concept of data lakes because we want to collect all of that data and we want to do something with it. So with that said, today's agenda, what we're going to cover is, number one, a high-level introduction to what Data Lake Storage is all about. We've got two of our friends and partners here to talk about the value that they can provide to our customers who want to use Data Lake Storage. We'll touch on some of the security aspects of that, and we'll just wrap it up for Q&A with all of you folks. So going back to the data lake. What is a data lake? Essentially, it's a giant big repository for you to bring all of the data that you think you might want to use in the future. You might not know what you want to do with it yet, but you want to put it in one place and figure out at some point, late binding decision on what you want to do at some point in the future. So what do people expect from a data lake? Like I said, 2.5 petabytes of data in a day, so that's a lot of data. So when people want to put data in a data lake, they think huge. They want massive scale to handle petabytes of data, and they want that scale to grow as your need grows. So that's one thing they're looking for. Second, security. I've got a whole bunch of data in there. I don't want everyone to be partying there. So I need a way to kind of secure my data, control access to it. If I'm going to be processing data, I don't want to be waiting for days to get the results. I want it to be quick. I want it to be fast. So people want performance on a data lake when they start doing analytics on top of that data. Integration friendly. What does that even mean? When you build an analytics solution, it's not just about I put the data in and I compute on top of it. There's an entire ecosystem around doing big data analytics. Yin here will also touch on the complexities of actually doing things like ML later in the discussion today. But the key point here is, for you to build an analytics solution, you've got a lot of microservices, if you will, or pieces that you've got to fit together to make your solution work. And so when you have a data lake that's storing all of that data, you want that solution to be integrated with all of those pieces such that you can build that solution seamlessly. So that's another criteria that people have in that data lake. And last, it better not cost me an arm and a leg. So they're expecting the ability to store data at fairly cheap costs. And at the end, if I stick that data in and it's super hard for me to go and manage it, not very efficient for me. So they're also looking for data management capabilities. Can I move data around? Can I see how I'm using my data? Do I have backup? Do I have disaster recovery options? Do I have governance? So essentially, this is what people are looking for in a data lake. Now, we introduced to you Data Lake Storage Gen 2, sorry. So Gen 1 and Gen 2, we'll touch on that a little later. For folks who've been with us on this journey, we do have some customers who've been on the Gen 1 of the product. We call that Azure Data Lake Storage Gen 1. We're talking to you about the Gen 2 of the product. How do we help you with all of the requirements of a data lake? Number one, security. What kind of security features do we have for you? Encryption of data at rest, encryption of data in transit. We have ability for you to actually do access control using role-based policies, policies on folders and files, a lot of fine-grained security capabilities that you might not have in other object-based storage systems. Second, I want to be able to manage my data. If I bring my data in and I want to, say, delete data after a certain period of time, I want that to be easy. If I want to move my data from one tier to another, I want that to be easy. So I want to be able to manage my data fairly quickly. Third, like I said, fast. How do we make that possible? Number one, we take all of the actions that you take on that data away from the client. We put that on the server. And so we try to avoid all kinds of round trips between the client and the server, so we make it fast. We give you enormous amounts of throughput. Analytics engines do a lot of activity on that data, and if you have throughput as a bottleneck, your jobs are not going to run very fast. So the data lake store gives you very high throughput that you will not see in non-analytic storage-based offerings. Scale. Folks who've been with us know that in some of our older, in our other products, we initially had limits in terms of how big your account can be, how big a file can be, how much throughput you can get from a single account. We know it's a problem. We've helped fix it because for an analytics store, if you're unable to scale and give that kind of throughput, it's not going to be it's not going to be a very good experience for those analytics customers. Cost effective. Again, going back to the previous offering, which was the Gen 1 offering, when we shipped it, it came at a certain price point. Feedback we're getting, you're making it so expensive for me to put my data that I want to process. With Gen 2, we're addressing that. We're going to give you the Gen 2 service at a much lower cost, almost the same cost as the blob object storage. So we'll talk about that as well. But essentially, think of this as almost half the price of the Gen 1 storage platform because we're giving you storage at the cost of object storage with maybe a little bit of extra that when you transact on that data. So that's the pricing model. So very cost efficient. The other way you also save on cost is how you transact against that data. Because we've moved a lot of that processing to the server side, the amount of transactions you're doing against that data is way less. So you're getting both those benefits, both the price reduction as well as the reduction in transactions when you act on that store. And last, integration ready. We are fully integrated with all of our analytics engines. HD Insight, which is the Microsoft analytics platform, Databricks, and you'll hear from Yin on exactly how they work with the storage platform. So all of the first-class analytics engines, we partner with other providers like Cloudera, and we're integrated with them. So first-class integration with all of the Hadoop vendors, such that you can run your analytics very easily on the platform. So in a nutshell, what is Gen 2, right? Gen 1, if you look at let's start with Blob Storage. Blob Storage is an object store. It's been around at Microsoft for years. It was designed with a very specific purpose in mind. You've got files, music, video, VHD images. You want a place to go and store it. Come store it on the object store. In terms of what the object store offered, number one, everywhere. You didn't have to be tied to a specific region, so we were available in all regions. BCDR capabilities. So you had LRS, GRS, ZRS, and if you don't know those terms, it's essentially redundancy options within the data center, across data center, within regions in a data center. Several options in terms of how you want to store your data and have multiple copies of that data. Options based on temperature. If it's hot data, I pay a certain price point. Cool, archive, different price points depending on how actively you're using that data. Cost efficient, like I said, Blob Storage was very cost efficient. We were very price competitive. And last but not the least, like I said, when you're building solutions, you need a partner ecosystem. Blob Storage has a humongous partner ecosystem. If you can go onto the Microsoft websites, you'll actually see how many partners we work with to help our customers be successful. What's the data lake store in the Gen 1 product? It was built and designed as an analytics store. So what did we do? We said file system capabilities. We want HDFS file system capabilities such that we can interact with the analytics engines, like the Hadoop engines, Databricks, HD Insight, all of those. So it came with those file system capabilities. It had a hierarchical namespace, which meant I can access things as folders and files, and I could put security and access controls on those folders and files. Tuned for performance. It was much faster, high throughput. The jobs ran faster. Again, since it was built for Hadoop, the storage platform allowed you to run analytics on top of it. So you have two separate services that Microsoft was offering. One for bringing your data, storing it, doing a whole bunch of analysis on it, cost efficient. And the other one, awesome for analytics, but probably not some of the benefits of the other. Gen 2 brings them both together, and you get both. I can have my cake, and I can eat it too. So I get them both in one service. So let me hand it off to my friend here, James. He'll talk to you about the architecture and exactly how we've built the analytics capabilities on top of our existing blob storage.
Thanks, Raji. So this session promised an architecture slide. Here we go. Here's an architecture slide. The key thing, and as Raji sort of pointed out, ADLS Gen 2 is built on top of blobs. It is the blob storage service. And so, the key point I want you to take away from this slide is that all of the capabilities that exist in the blob storage server today, living in that bottom layer there, are fully available in ADLS Gen 2. It's not a choice that you have to make of saying, oh, okay, do I want this set of qualities or that set of qualities? We said, this is all converged down, and this is the way we do it by platting it on top of the blob storage service. So that's sort of the key point that I want you to take away from this. This is blob storage, but it is better. And the betterness is the piece that sits above there, which is designed and dedicated towards doing analytic workloads and meeting the I/O patterns that these frameworks present to these workloads. And one of the key points about that is we build a hierarchical namespace in the storage service itself. So those of you that know and are familiar with object stores, you'll be aware that it's just a flat namespace. Even though there's lots of convention about embedding slashes in names, they are just strings. And the storage service doesn't impose any semantic on that. And, while that does work, it presents sufficient sort of friction that some of these operations degrade. And the most common one that applies specifically to analytics is directory management. It's very common in these big data frameworks to go and output data into, say, a temporary directory, and then at the conclusion of that workload, it's sort of the poor man's concurrency control. They just simply rename the directory to the final output and call it done. On something like HDFS, that's no problem. It's a metadata operation in the name node. It all happens instantaneously. And that's what these frameworks assume, that capability. However, in object stores that don't have notion of directory, don't even actually have a notion of rename, that nets out to n copies and deletes. And that, while that's not an expensive thing, what it is performant inhibiting. And so by building the hierarchical namespace directly into the storage service, we get that ability to go back to being file system semantics, an atomic metadata operation to do things like renames. It also allows it to present as a sort of familiar management service. So you really do get directories as first-class things. And that's sort of critically important. One of the other aspects on that, and what I want to underscore is, that is one of the key drivers of the performance improvements in ADLS Gen 2. And while, that's sort of not super impactful from the amount of money you pay for your storage options, when you think about, probably 90% of your bill in cloud analytics is from the compute layer. And that's all paid for over time. If you're reducing that time by up to 20%, even more in some cases, that's 20% of 90% of your total workload, significant cost savings. And so that's the driver behind wanting to do this. It delivers genuine performance. And Yin will show us a demo in Databricks later on that shows really how much performance improvement you get out of that. The other aspect in the box on the right there is security. So one of the things that, again, all of these analytics frameworks expect is a POSIX-compliant file system so that they can go and apply ACLs across the top of that. And when you don't really have directories, you can't be POSIX compliant. You can't put an ACL on a directory and say, okay, every file that I create in that directory defaults those permissions, because there is no directory containment. Once we get a hierarchical file system in there, we can go and do those sorts of mechanisms, and we get true POSIX compliance. And that point was probably lost in the earlier days of big data analytics, which were a little bit the Wild West. We had this just massive repository of data, and we didn't worry too much about, sort of the fine-grained access on that. But in a world where we want you to go and build enterprise-wide data lakes, and you might have some of your engineering data in there, and you might have some of your sales data in there, but you've also probably got some of your HR data in there. the HR folks don't want to be sharing their data with the engineering folks. And so you have to be able to have a permission mechanism that rolls out across that is compatible with the analytics frameworks, and you've got management tools over the top of that. And so fine-grained ACLs is the way that you go and get managed that. Obviously, we need to make that scalable and policy-driven, but at the end of the day, the fundamental primitive is the ACL that lives on the directory or on the file. The other aspect of that, and one of the reasons why file systems didn't really happen in the cloud, and we gravitated towards object stores, was that we knew how to make object stores scalable and cost-effective. There was very little overhead in storing a flat list of objects within your accounts, and we could scale that out horizontally all day and all night. And the prospect of saying, oh, okay, well, I've got another layer sitting above that hierarchical namespace layer, traditionally has presented an impediment to being able to achieve those scale and cost objectives. And so what we've done, and the main work we've done, is implementing the hierarchical namespace in a way that is scalable and is cost effective. And as Raji said earlier, we're able to do that at the same price point that Blobs is today. So there is no cost penalty. Beyond that, right at the top there, we do actually expose 2 API endpoints over the top of this shared data set. And that's sort of important because we still want to be able to use the existing object store blob infrastructure. So A, there's a huge ecosystem that's already working on blobs, and B, there's many sources of data that like working in an object store space. As Raji said earlier, if you're building up a store of images or music files, that's a perfect object store scenario. And so we want to be able to continue to use those APIs to work with your data. But then we've got a file system-based API, the ADLS API up there, which converges on the same data set. So we're not creating silos of data. But because it's a file system-oriented API, it has the things you sort of expect. You'll be able to traverse a directory structure. You can open a file, write to a file, close a file. And so those things are important, again, for the analytics frameworks that expect those sort of semantics. And we're not presenting a sort of any additional friction in the storage layer when we're doing I/O. So that's basically the structure of it. Again, the point I want you to take away, it is blob storage, but it's blob storage with added extras over the top of it. So now I want to sort of pivot to some of the patterns that we see in the analytic workload that we do and how we sort of address those on the platform, on the Azure platform. For a long time, we sort of thought, and you know, we love building platforms at Microsoft and say, okay, well, there's a whole pile of Lego bricks out there. Here you go. Here's the bag of Lego. Go knock yourself up, whatever you need to do. And that's still a good answer. But what we also found was that many customers are saying, you're not giving me an instruction manual with this Lego brick. Please tell me how to put these things together in such a way that, I can do the work that I want to do. And in big data analytics, there are a limited number of patterns of processing of data that we want to do. So what we've done is go and rationalize down some of those patterns and say, okay, let's codify them in a way that, becomes a little bit more prescriptive about it. It's not saying that you can't vary from this, but let's think about patterns as a useful, reusable sort of concept. And so the first pattern that we see, and certainly the most popular pattern, is what we call the modern data warehouse. It's taking what we would have done in a more traditional, maybe on-prem BI pipeline, moving the data out of operational stores, moving it through into a data warehouse, maybe a data mart, and then consuming it in some sort of reporting or dashboarding layer. So the objective is the same. The architecture, however, is slightly different. And the key change in that architecture, instead of moving the data from location to location to location or engine to engine to engine, what we're saying is you ingest the data into the platform directly into that ubiquitous storage layer, which is ADLS Gen 2. And then you bring the analytics engines to that capability and you go and iterate on that data in place. even to the point where some of the data warehousing approaches that we can say is that you don't even need to ingest the data into the data warehouse. The data still stays in the data lake. And the data warehouse gives you that interactive query capability that can go and drive your dashboards. And so this is what we're sort of talking about in terms of modern data warehouse. There's a variation on this, which we're sort of calling advanced analytics, which is very similar in appearance, but has a variation of, say, you can now drop in things like machine learning into that same pipeline and augmenting those pipelines with machine learning capability. And while that's great, what another variation of it is, you see on that sort of top fork on the right-hand side, is the way that that data gets consumed. So instead of being consumed by a report, you can just feed that back into your application. And so if you think about the way recommendation engines work, is that they're driving that back into their application so that when you're clicking onto the next, they're saying customers also bought this. And so that's an example of how that particular pattern nets out. The other one, which is probably more in the emergent space, but is certainly mainstream and becoming more and more popular, is the notion of real-time analytics. And the fact that, the sort of classic architecture of saying I've got a hot path through that real-time data, so I'm doing some initial analysis as the data arrives, but then I'm being able to batch it up and do some different types of analysis as that data is in the aggregate. And so that pipeline allows you to fork your hot and cold paths and still apply the same technology sets. And this is the key point about it. You don't have to think about doing something very, very different for streaming and very, very different for batching. The same technologies, even the same code bases apply to both the hot and cold path. And then it's just a matter of how you go and consume those results. So that's sort of an overview of some of the patterns we are finding, and customers sort of telling us that that's useful because, while choice is great, sometimes just being a little bit more prescriptive in saying what you should be able to do and what we're optimizing for is a key element of that capability. So with that, I want to now hand over to Yin, who's going to talk to us about Azure Databricks service and how it relates to the ADLS Gen 2 capability.
All right, thanks, James. So hello, everyone. I'm Yin from Databricks. So today, I'm very excited to join the Azure Storage team to tell you how to use Azure Data Lake Gen 2 with Azure Databricks. So extracting values from data in an efficient and effective way is a hard problem because lots of different skill sets are required and lots of complex systems are involved. So this problem can be better illustrated by this figure in the paper, Hidden Technical Debt in Machine Learning Systems. So this figure shows different kinds of components involved in building real-world machine learning systems. As shown by this figure, only a small fraction of those real-world machine learning systems is composed of the actual machine learning code, which is a small red box in the middle. So in order to get machine learning code work efficiently and effectively, so many surrounding infrastructures like data collection, data preparation, and configuration management are required. So those surrounding infrastructure are complex and lots of efforts are required to get those things working smoothly. So besides the challenges of building and maintaining different types of complex systems, people in the same organization, but with different types of personas, are often disconnected. So data engineers deal with large-scale data processing and production deployment using one set of systems, but data scientists dealing with AI, exploring data, and training and validating model use a different set of systems. So this organizational separation creates significant friction and slow AI initiative considerably. So at Databricks, our goal is to accelerate innovation by unifying data science, engineering, and business. We are addressing those different data challenges with our unified analytics platform. For Azure, we provide a cloud-native service, which is Azure Databricks. Azure Databricks eliminates significant infrastructure complexity, and it brings people with different backgrounds and different skill sets in the organization together under the same platform. So people can collaborate smoothly to achieve joint goals without spending tons of energy and time on managing complex data infrastructure. So in Azure Databricks, Databricks Runtime is the engine for data management and data processing. Databricks Runtime is powered by Apache Spark, and it has been optimized by the Spark expert for the cloud environment. So with Databricks Runtime, you can work with different types of Azure data sources, like Blob Storage, Data Lake Storage, SQL Data Warehouse, SQL Database, Cosmos DB, and even Hub. And also, we have the different types of tools provided by the Azure Databricks workspace to fit different types of use case. So let me give you some example. For example, so you can use Azure Databricks to run and manage production workloads using Databricks jobs. You can use Azure Databricks notebook and dashboard capability to explore your data, run ad hoc queries, and build models, and then share your results with other people in the same organization. You can use the APIs provided by Azure Databricks to integrate Databricks with your other data engineering toolsets. You can also use your favorite BI tool to connect to your Databricks runtime cluster and start to use those tools to explore data, analyze data for the data from different types of data sources. And also, the Azure Databricks is integrated with the Azure Active Directory, which simplifies the user management and also serves as a foundation for deep integration between Databricks and other Azure services. So now, I'd like to share with you 2 upcoming features for the Azure Databricks and Azure Storage, Azure Data Lake Storage and 2 integration. So the first one is identity-based authentication, which is powered by the deep integration between Azure Databricks and Azure Active Directory. So right now, when you access your data using like different types of analytical platform, you often need to have a shared secret in order to authenticate with your online storage. So those shared secrets can be like shared, for example, storage access key, like shared service principle. But those shared secrets is often pretty hard to manage, because people often share those secrets around using email, instant messages, or just simply sharing the notebook. And also, it's really hard to audit data access, because those secrets do not usually carry identity information. And it also is a fact that the multiple users actually share the same secret. So it's really challenging to tell who actually accesses your data. So with the deep integration between Azure Databricks and Azure, so now we can provide identity-based authentication. So we have been working on this support, and it will come in near future. So specifically, we will have 2 types of identity. The first one is a user identity, which represents the access token of a user who runs a command. So basically, if a data operation is triggered by a user, Databricks will use the identity token to associate with this user to authenticate with the underlying storage. So now let me walk you through the workflow. So let's say a user triggers a command through a Databricks notebook that requires a Data Lake Storage and 2 access. Since Azure Databricks already knows who is triggering this command, so the Databricks notebook service will send a request to Azure Active Directory in order to retrieve the client ID and the token associated with this user. And then once the Databricks notebook service got the client ID and the token, you will send these 2 pieces of information along with the command to the backend Databricks runtime cluster. So those information will first run it in the Databricks runtime driver, and then when the Databricks runtime cluster start to run the command, the driver node will distribute those information to the executors who run those commands. So now those executors got the access token, so they can start to access the backend Data Lake Storage Gen 2 account. So because with the user identity, so for the interactive workload, we don't need to use a shared secret. So now we can just let the application to use shared principal. Basically, if we have a scheduled job, like a Databricks jobs, we can assign a service principal to the job, and then the job will use that to access the underlying storage. So that's the identity-based authentication. So the second feature upcoming is the mount point support. So if you are a Databricks user, you're probably familiar with the Databricks file system, which is DBFS. So DBFS gives user is provisioned with every Databricks workspace. It's a default storage system. It's give a user really easy and nice way to start to use Databricks. And also the DBFS make it easy to work with your data because DBFS itself will handle the authentication. So basically the mount point here means you can create a mount point under the DBFS namespace or your Azure Data Lake Storage Gen 2 dataset, or like a con or like a container. So then you will not need to use the long path to the underlying Data Lake Storage Gen 2. Instead, you can use the shorter and easy to remember Databricks DBFS path to access your data. And the mount point, once we have the identity-based authentication, the mount point will take advantage of it. So you will not need to provide any credential when defining or accessing your mount point. So basically, if you or your application has access to your underlying storage, you will be able to just use a mount point. So those are the two features upcoming. So now you may have a question like, how about now? So what do we have? What are available today? So the Azure Data Lake Storage Gen 2 is supported by Databricks Runtime 4.2 and above. So you can use ABFS or ABFSS file system scheme to access the data, like how you access other Hadoop-based file system, for example, like a Blob Storage or like Azure Data Lake Gen 1. And we have been testing the performance of Azure Data Lake Storage Gen 2, and we're excited to report that we have seen significant performance improvement in our internal workloads by just switching the underlying storage system. So our internal workload usually shows 20% and above improvement. And with the Azure Data Lake Gen 2 support added in Databricks runtime, users' data in Gen 2 will naturally be part of the rich data ecosystem empowered by Azure Databricks. And you can start to flow your data in and out from the Data Lake Storage Gen 2 and then build your data pipeline, and very easy you can start to switch your existing data pipeline to use Gen 2. So now let me show you a quick demo on how you can use Databricks to access Gen 2. So this is a landing page of Azure Databricks. So we already have a cluster running, which is called ADLS Gen 2. It has in total 9 nodes, 1 driver node, 8 worker nodes, they're running standard L4 instance. So now I have 1 notebook. So basically, through this notebook, I'd like to show you how to work with Gen 2 in Databricks and also show the performance advantage of Gen 2 compared to Blob Storage. So in this demo, I'm using the flight dataset, which is airline on-time statistics and delay causes. So for the comparison purpose, I have already saved the same dataset in both Blob Storage and the Azure Data Lake Gen 2. So first, let me set up the data access. So basically, in order to do a like storage performance comparison, the first thing I do here is like disable the DBIO caching, because you will boost the performance of I/O. But here I want to really get all of the requests hit the backend, so I disable this optimization. And then, so now I need to get the credential for the online storage. So here I'm using Databricks Secret, which allow you to integrate your security in the key vault into Databricks. And now I got the 2 credentials, one for my Blob Storage account, another one for the Azure Data Lake Gen 2 account. So now I put the credential in the configuration and set up the access path. So now I will be able to like check out the data in those 2 data sets. So basically here I'm showing all of the directories under the data set. So you can see there are in total like 8 partitions for the WASP side data set. And we can see we also have 8 partitions in the Azure Data Lake Gen 2 side. So basically the identical data set stored in 2 places. So now with the Spark's data frame API, I create like one data frame, basically call spark.read.load, and to create a data frame representing the data set in the blob storage. And then I create a view for this data set to make it usable in SQL. And you can see I'm using the same API to create another data frame for the data set in the Azure Data Lake Gen 2. So now I have the 2 data frames representing the same data set from 2 different storage backends. So now let me show some simple benchmark results. So the first query I like to show it here is like very simple count star. Basically, I want to count the total number of rows for the data set stored in Blob Storage and the data set stored in Azure Data Lake Gen 2. So you can see here, this is the time spent on doing this slide count star. So here we can see for this Blob Storage data set, the cluster spent 1.5 minutes, basically in like 90 seconds, to do the count, to count the total number of rows. But for the Azure Data Lake Gen 2, with the same query, same data set, we only need to spend 50 seconds in order to do the total number of counts. So the second query is a group by query reading a single partition. Because this query is like can finish pretty fast, I'd like to run it here. So now let me trigger the query for the blob storage data set. So while this query is running, you can actually check the status of the query by looking at the Spark UI, and you can check the amount of time spent on different stage, and also the amount of the time spent on each task. So for example, for this query, it spent 20 seconds to finish. You can see there's like one stage that takes the most of the time, which is like just scanning the data, and the median duration of a task is 6 seconds. So now let me run the same query for the data set stored in Azure Data Lake Storage Gen 2. So the query is running, looks faster, and let's see, the duration of task looks shorter. Great, it only took 12 seconds to finish. And if we look at the median duration of the task, it's 4 seconds compared to 6 seconds before. So basically, same query, same data set, just swapped the underlying system. We got like out-of-the-box performance boost, which will get your data pipeline more efficient. So, all right, that's the end of my demo. All right. So, if you would like to try out Data Lake Gen 2, Data Lake Storage Gen 2, I encourage you to try out with Azure Databricks. And I also encourage you to try it out with your data pipeline, so you can get a sense on how it can help and start to plan the migration. Thank you.
Thanks, Yin. And quite frankly, if those performance numbers aren't compelling enough for you, I don't know what else I can do. Like that is almost a 50% improvement over what was already the industry-leading performance benchmark. So this is a significant jump forward in what we're capable of doing. And, I'm going to keep pounding this message out to everyone. It is faster. It will be cheaper. That's the end of the result. So another aspect we've sort of touched on already a little bit is the security aspect of it. As I said, there was a time in big data analytics when we're in the Wild Wild West. We didn't really care too much about the data and the security of the data. 2018, data is gold. Data is the IP of many, many companies, and you want to go and protect that IP. And so security is no longer a secondary or ancillary consideration. It is one of the primary considerations. And so obviously we've spoken about the access control aspects, and that's super important. The integration into the analytics frameworks, the integration into management tools so you can go and control those ACLs and set them into policies. It's all super important. But what I will say is that security doesn't end at just permissions. Security is also about encryption. How do we ensure that the data can't be stolen? Someone can't compromise either your account or a Microsoft data center and walk away with your data. And so it's super important it's encrypted. Now, all data is encrypted by default. By default, we use Microsoft managed keys to go and encrypt that data. Now we've got an ability for you to bring your own encryption key. Going forward, we're giving you an ability to apply encryption keys at the file system /container level. And then going forward from that, we may even be able to apply encryption at very fine-grained levels, which certainly helps these sort of multi-tenanted scenarios or where the encryption is a hypersensitive requirement. There's also encryption in transport, super important. For a long time, especially with WASB driver, TLS you took a significant performance hit. You took sort of a 20 or 30% performance hit in doing encryption over the wire. With ADLS Gen 2, that is now plus or minus 3%. So we've had significant improvements with the SSL engine, encryption at transit, and certainly when you're doing that in combination with secure access, by default is now a viable option. There's also network level protections as well. You've got all of that data sitting out in the cloud. It is on a public IP address. And so you want to be able to ensure that you can lock that down at the transport level, at the TCP level. And so a firewall or VNet service endpoints as they're called, but storage firewalls is the term from the storage perspective, is a mechanism whereby you can control exactly what destinations and what services have access to that data. Again, super critical, and layers on top of the authentication piece that we've also got. And then there's another piece coming soon, the VNet service policies, which allow you to define policies about how the data goes out. So you can apply egress restrictions on that or exfiltration restrictions going forward. And so this is a complete approach to securing your data, giving you the confidence that bringing your gold into the cloud and onto Azure is a viable thing and you're not exposing yourself to security compromise. Super important aspect. This is where we're spending a lot of time in building up capabilities. They're also building up at the blob level as well. So this is an example of a feature that we're transitively inheriting into ADLS Gen 2 because it's a capability that's built into the blob storage service. So with that, I want to welcome Jordan to the stage. He's going to talk about the Tunity's integration with it and talk about some of the ways that Atunity's moving the data and taking advantage of ADLS Gen 2.
Perfect, perfect. Well, thanks everybody for being a part of this overall experience where what I'm going to do is extend on some of the things that they've already been discussing. And one of the things that we discussed today is going to be part of the way that you're going to take your enterprise historical systems and load them into other platform tools. So one of the things that we talk about today is, not only the Attunity team, what we've built has moved about 100,000 databases last year to the cloud. That kind of marks the significance of people are adopting this. People are buying into not only the cloud, but how my data lake needs to be designed. That's why ADLS is not only the best product on the market for loading into from just my own personal, but like from what I'm seeing here is you look at all these different databases that are over here. These are what are running the backbone for your business. You may be running things in SAP. You may have a legacy platform on a mainframe. You may be taking your SQL servers like 2008, 2012, even 17 to 19. You may want to upgrade those. You may want to take them from your on-prem systems and migrate them, even to managed instances. We talk about those, right? So there's all these different targets here. And what we started to look at was, as a team, at Attunity, we started looking at the significance of scale, right? We've got customers loading into ADLS with, I would say, over 300 separate databases loading. I mean, that ends up being, with the way that we've built Gen 2, over 100,000 tables can be loaded every second in certain scenarios. You're talking about really large-scale investments and large-scale operations, and these are some of the considerations of what happens when you're loading. You want to be able to have that consistency and comfort. This is what we've been doing with our product, is making it really easy to migrate to these new technologies. So if you've got a database schema that changes, you want to change with it. That's a natural way. You also are going to have people that are not going to want anything to be installed on those systems, especially if you don't even own them. They're on some other cloud, right? So those are the type of migrations, and as well as all the parallelism that you want to be able to deal with. And when you're loading ADLS, and what I'm going to do in this demo is a short purview into the overall landscape of Azure. And let's say I've got my SQL systems. What I'll be looking at and showing you to start is an Oracle and a SQL instance that get migrated over, but they get pulled over and they're loading into ADLS, but also you can load all these different systems. Databricks can pull off of event hubs, but it stores off event hubs and processes in ADLS. It also could then go into SQL DW or other tools in there, and at the end I'll show Power BI hooking off of Spark. So what I want to do today is hop into, and let me hit the button. Okay, cool, you can see it. All right, so what I have right now is the Attunity Replicate console. This works, your Linux VM, Windows VM, install it. This is the UI. But what's really simple about this is that it's a drag and drop interface. Right now I'm loading a bunch of different platforms and systems, like my localized Oracle. I've got 3 or 4 different SQL servers on this machine. And you guys can download from the website and set up this VM at any time. This is available to you, sets it up on Azure. But what's interesting about this is I'm loading ADLS in 2 different use cases. I'm loading from an Oracle database to one bucket and another SQL server in another bucket, and I'm loading SQL Data Warehouse from those same buckets. And what I want to show you today is how we're loading all these different components. A lot of the time you have to configure all of these endpoints. So we're picking up that security over time as well. And that's part of the Gen 2 security model that gives us a lot of that flexibility. And when you configure all this, you have to, there's an ease of use that's incorporated into working and navigating Azure, right? We all have those fun experiences of trying to understand how to navigate the console. So what we do is we make it really easy. We're talking about like loading files, making sure they're compressed just because of the size of it. But there's also something important. When you're loading a data set and you're wanting to be able to do a migration, not just a one-time migration from like that SQL server, but you want to, it's a live production system. When you're looking at it from that standpoint, what you're trying to do is to consistently load it over time. So we work with our technologies, part of change data capture. You hear a lot about that. It incorporates well with like the Delta technology from Databricks. So when you look at it from that standpoint, you're looking at the level of ingestion. So I'm going to get to, through my part, we load into ADLS. That's what I've got here, this job. So I was able to traverse a localized database schema. I think everybody recognizes AdventureWorks over here. But I'm pulling through the AdventureWorks database and being able to migrate it very, very efficiently, slice and dice through complex schemas. There could be a lot of different data that you pull through. So as I've loaded this and configured that instance, now that I've got that hooked in real time, it's now loading, right? what I'm able to do is I've set up a number of different instances on my Azure resource group, and I go into my Databricks workspace. Click over here, and I go into the Databricks console. What I took was that data that it just loaded. I had to go mount we talked about mount points, configurations, those type of scenarios. So I had to be able to put in some of the code, but as I authenticated my account, which was the same one we loaded, we picked up from what we talked about, that mount point, these databases and files, right? And what we've done by mounting that point, that's the mount point here. There's the classic data sets right here, but then there's the one I just loaded using replicate. And what I'm able to do in this section is I'm loading and creating, all I'm doing is creating column headers. The other thing that's interesting is I'm inferring the schema, which is one of the things you talk about with Spark that gives you a lot of flexibility. Is you're porting all of your database functionality to these scenarios. You get the ability to create what we're talking about, which is the data sets, the data frames we're talking about. As we look at it, I created and dropped it. This is just a standard step. But then I loaded and saved it into tables that are all within my environment. Those tables are now readily available and available from Databricks, but they're also now readily available to me in Power BI. So what I was able to do was I loaded this whole process to get from a SQL Server data warehouse, loaded it into the cloud, configured it, figured out my endpoints, took me less than 20 minutes. That's figuring out where everything is, putting it all together. And that's what's the ease of use of being able to get to these scenarios. I'm able to take Power BI, and once I get to Power BI, I go to this more area, and I find the Spark right here, this part. And what I was able to do by clicking on Spark was being able to make it really easy to be able to connect my sources together and make it live and work. So what I'm going to do is hand it off to my team, and I will take it. It's 5. There you go. There you go, Raji.
Thank you, Jordan. So as you can see today, we have probably the most number of speakers on stage for any session that you've been at. It takes a family of us here on stage. It takes a village of partners to kind of make customers successful when they need to go and build a solution. So 2 of them on stage today. What you see on the slide is just another set of partners that we're working with currently. And as I mentioned before, we have a massive ecosystem of partners that have already integrated with Blob Storage. So this is just the start of our journey. We have an enormous set of partners that help us with various pieces of that pipeline that James was referring to. Whether it's in the beginning of the pipeline, migrating data from your on-prem systems to the data lake, whether it's ingesting from some application into the data lake, whether it's running analytics, whether it's doing visualization, the broad spectrum of use cases of that data in the data lake, we rely on partners to kind of help bring our customers forward. There's one question I just want to ask before we continue. How many folks in this room have played with Data Lake Store Gen 1? Okay, so I have 2 words for you guys. Thank you. And I'll tell you why I say those 2 words. Because it's because of the feedback from all of you that we're here today. You gave us feedback that you love the product, you love what it's capable of, but that you want more. Yes, that's always what we hear from customers, right? You want better, and you want cheaper. And that's what brought us to this journey today. So what I want to tell you folks who've already taken a bet on us is, number 1, there will be no forced upgrades to Gen 2. Gen 2 is where we are taking Data Lake forward. We know that you've taken time and investment and money to get onto Gen 1. We are not going to force you to get out of Gen 1 to Gen 2. You've made a commitment. We are making a commitment. You stay on Gen 1 for as long as you need. So no forced commitments to move out. The second thing, every time I talk to a Gen 1 customer, the first thing they say is, dude, you've given me everything I want. It's there in Gen 2. How do I get there? And so what I want you to start thinking about is, when you think about the upgrade, think about it in terms of 3 aspects, if you will. Number 1, applications that are sitting on that data lake. Applications like Databricks. Some of them might be as simple as, Databricks was pointing, and if you saw the demo that Yin had, I was pointing to an ADLS endpoint on that account. I just switch it to the ADLS Gen 2 on this account, and I'm good. It might be as simple as that. If you've written applications that have taken dependencies on our REST APIs or our SDKs, you might have to go and look at the differences in the APIs, and you might have to modify some code. So that's what you will have to take into consideration when you think about your application and how you move that. You might have metadata out there, ACLs, policies that you've created. Those will have to move as well. Data, you've created files. All of that content has to move out there. So there are various aspects that you will have to consider when you think about that upgrade. I've been in this business long enough to know that upgrades are not something you do overnight. And we as a company are committed to making sure that our customers are successful. So we are working very hard in terms of whether it's an application upgrade, whether it's the data or the metadata upgrade. We're working very hard in collaboration with some of our early preview customers to provide very clear guidance, both in terms of tools and documentation, very crisp guidance in terms of how you can actually make that jump from Gen 1 to Gen 2. So again, I want to reiterate, thank you for being with us, for giving us that feedback so that we could actually adjust our strategy such that you get more value from the services that we provide. And rest assured that we're not going to force you, we're not going to turn it off. You continue to be supported. And when the time is right, you can move to Gen 2. And so several of you are already on the preview program. ADLS Gen 2 is in preview. We've got several customers on the preview program. So I'm going to hand it off back to James, and he can walk you through how the preview program is doing and what we've got in store for you in the future.
Yeah, so as Raji's saying, we've been running the ADLS Gen 2 in public preview since late June. The customer response has been fantastic. It's far exceeded what our greatest expectations were. We certainly acknowledge that there's more we need to do, and we need to bring sets of features. We need to make sure we're delivering on those promises. But the response, the message that we're taking out, the adjustment to the roadmap has been certainly well received. One of the things we are going to achieve within the preview timeframe before we go GA is that we'll be in all Azure regions, including any sovereign clouds that you or your customers may be working in. And so that's one of the key qualities or the key value props of ADLS Gen 2, and we're making sure that's going to go and happen in time. As we've already seen, the integration is already in place. The sort of big data analytics frameworks, we've spent all of our time making sure that works really, really well. And so that's there now. And so if you've got a very Hadoop or Spark-centric workload, you should be able to evaluate how that works on ADLS Gen 2 today. And even in the preview state, we're seeing a lot of customers being very successful doing that. And the permission stuff is coming out. We were planning to have a big announcement about that at Ignite. Turns out we haven't been able to just completely deliver on some of that functionality. So the RBAC and ACL integration will be there very, very shortly, and we'll be making a lot of noise about that to the preview customers. And certainly by the time we reach GA, not only will it be fully baked into the service, but it'll also be baked into all of the analytics frameworks and all of the management tools that we've got, so you can get that full management experience and take advantage of those ACLs. For those that you aren't in the preview program, I'd encourage you to join up. We are having a sign-up form to join. It's a very simple form, and quite frankly, in any preview, it's about you guys getting early exposure to it, but also us getting that feedback from you. And so filling in that form is the way that we establish that relationship with you guys, and you can go ahead and use it. And we've got a Yammer group that we're sort of communicating with everyone, and so that's very, very active. And so people are benefiting from not only our communication to it, but talking to each other in there as well. So by all means, please go and sign up. The regional availability is expanding all of the time, and certainly love to hear from you. If you're have a need in a particular region that we're not there yet, please let us know and we'll get there as fast as we can. So that's ADLS Gen 2, and I really do believe it's going to be sort of transformational in what it brings to your ability to go and get value out of your data. And the storage piece is the foundational piece in being able to build that out. but there is much, much more that we need to go and do. And we're looking at many things that are additional to just the raw storage capability. And we love to hear your feedback on what you think is going to be necessary, what you think we're missing firstly, and then what you think can be the opportunities to go and take that further so that you can continue to get more and more value out of your data, or more and more security out of your data, or more and more understanding about your data. And so one of the things we're certainly looking at is, we hear this a lot from customers, they want to be able to, once they load data into the data lake, they want to be able to just simply query it very quickly. And so that's something that we're going to go and bring. We don't know exactly what form that is, but certainly you can imagine experience within the storage blade of the portal. There's a dedicated tab which has a query surface area. You can go and do ad hoc query in there, and based on a number of other things that we're building up, you'll get a SQL-like query experience of that directly out of the box. You don't have to go and spin up extra compute capability to go and get that done, so you can have an immersive experience with your data. The other piece that we hear very, very loud and clear is data classification and cataloging. Cataloging piece is solved today, but is solved in sort of piecemeal form. If you're in the Hadoop environments, you're looking at H-catalog spaces. If you move that data into SQL DW, you have to catalog it separately. If you move that data again onto Power BI, you have to catalog it separately again. And so the goal with this is to be able to have a ubiquitous cataloging capability where the data lands into the data lake. We have sort of runners that automatically discover your schema, automatically apply classifications, and then that metadata persists with that data all the way through the journey of its life cycle. And so this is a strong piece that we want to do. Cataloging is just the first piece. Layered on top of that is things like governance. Everyone's talking about GDPR. For a long time, we were sort of saying, oh yeah, well, we're GDPR compliant, and so therefore, it's an application concern to get yourself GDPR compliant. Turns out there's not that many patterns that we need to go and solve for to be GDPR compliant in your data management. And so we're now going to say, yeah, we'll probably be able to make you GDPR compliant by having the right level of governance tools. Data quality. Long pattern. I mean, I was in the SSIS team 10 years ago. We were trying to solve data quality issues back then. We're still trying to solve data quality issues. Now we're trying to solve it on big scale, big data scale. And so that's another thing we need to come and bring and have a compelling offering. And that may not be necessarily a Microsoft first-party service. There are many, many partners, and we're going to tap into that ecosystem so that the partners can bring those sort of data quality pieces as well. And finally, the sort of master data management pieces as well, a long-running problem for folks, especially as you build up these heterogeneous data lakes. If you've got 40 references in your data lake to a customer, what's the real reference to that customer? How do I know what the unique thing is? And how do I know what this data is that augments it? And is this the same customer? And all of those things. Again, long-standing problems. We don't have great solutions for that today, but that's certainly something we're going to be looking at in the near term. So that's it. Yeah.